I'm going to give you the general equation for cosine, and then we'll graph one of these with all the transformations. General equation. Come on, are you making fun of my handwriting? For cosine. And now we're going to include all the transformations. Alright, so here is the form we have arrived at now. And this will work for sine or cosine. I'm just writing it for cosine. With all of your transformations. And do this on the, try to keep it on the left side because I will be adding something to the right side later. Not today, but next week. Alright, now we're going to go through each of these and quickly talk about what each of these do. So I'm just going to underline it and I'll ask you what is this, how does this transform the graph? What does my A represent? Amplitude. Or your vertical stretch. Good. What does our B represent? Good. Angular frequency. Which probably is the most challenging part of this for most students. Because this isn't the period length, it's the angular frequency. How is this related to the period length? So what's the equation, Anthony?
It's the period length, right?
Uh-huh.
B equals 2 pi over P.
Uh-huh. B equals 2 pi over P. Perfect. And you can switch the B and the P either way, it'll work. H and K, they continue to come back. This is your logo project. H is what? Horizontal shift. And K? Vertical shift. Alright, so this is as complex as the sine and the transformations are going to get. We will, though, next week learn how to gradually shrink or gradually grow this graph, okay? We're going to actually combine this. It's going to sound really strange. We're going to combine this with an exponential function. So chapter 3. But for now, this is kind of where we're at. Go to the bottom. And on the bottom, we are going to graph one of these. And you're going to do most of it. I'm just going to start you off. And this will go on the bottom flap. And CPM refers to this as the 5-point method of graphing. Just because the box allows you to have 5 points to complete one cycle. Yes. The one with all the different, you create the box and then you graph it. Some of you guys, raise your hand if you're already noticing shortcuts with the box, like you don't have to go through all the steps. That's great. You can kind of, remember I said it was training wheels. If not, you can work through all the steps. So you can kind of apply the same process to this. Graph y equals -2 cosine pi over 3 x minus 2 plus 1. And we're going to state the domain range. Alright, so we'll take up this whole bottom flap, we'll do all the algebra on the left, and on the right we'll graph it. Alright, so same kind of steps. What's the first step? Yeah, we're finding what in our graph? The starting point, so we're finding the beginning and the end of period. And I won't make these as detailed as we did the first time because you're aware of it. Now, on your chapter 4 test, I was nice because we hadn't got here yet. I took this out, right? And all you did was set pi over 3 times x equal to 0 and 2 pi, right? But now we have a shift and a stretch. And this is all horizontal movement because it's inside of the parentheses, right? So we're going to take this entire expression and set it equal to 0 and a 2 pi. That's kind of what you just did in 67. with the Lowell and Hardy problem. So pi over 3 times x minus 2. We set it equal to 0. And then we do the same thing on the other side, but we set it equal to 2 pi to find the beginning and the end. Now, I'll work the left with you, and then you can work the right. So you guys just did 67. What's my first move here? How do I get x alone? I could divide by pi over 3, right? But this is a fraction, so what's an easier way to get rid of it? Reciprocal. Whenever you see a fraction, multiplying by the reciprocal is going to be easier, because then you don't have to divide anything. So multiply by 3 over pi, multiply by 3 over pi. Nice thing, they cancel. You get x minus 2 equals 0. Comes out nice. Where's our beginning point? X equals 2. Okay? That's where we start. All right, go ahead and figure out where we end. Same process, use it on the other side.
X minus 2 equals 6 pi.
Yeah, and then the pi's crossed out, right? And you're adding 2, and then you're 6. And then you add 2, and you get x minus 5. Wouldn't it be 8?
Well, it's x minus 2 equals 6. And then add 2, you get 8. All right, you guys get 8?
Yeah.
Summer pointed out something that I'm sure some of you are noticing. When your angular frequency has pi in the numerator, what ends up happening? You have whole numbers, right? It's a little bit easier to work with. All right, beginning and end. This is a little different because in the last test we always started at 0. Now we're starting at 2. What's step 2 here? Subintervals. All right, and after this you're going to finish the rest of it on your own. So subintervals. Now back in chapter 4 when we started, you always took your period length, which was 2 pi. Is it 2 pi anymore? No, in your project there's no way it's going to be 2 pi. It's going to be something different. Can we just look at this and find our period length? Yeah, what is it going to be? 6, perfect. 8 minus 2 equals 6, and then what do we divide 6 by? Yep, you're dividing it into 4 quadrants in the unit circle. This will give you 3 over 2 or 1.5. Okay, now this is the other place I'm seeing the mistakes. Usually the mistake's in here or it's in building your graph. So let's start building our graph. Kind of reiterate this. All right, find your start and your end. Starting at 2, ending at 8. Now how do we divide up our graph all the time? By 4. So we start by cutting it in half, and then we're doing the half and half. Now go ahead and add in your subintervals of 1.5. All right, once you have that added in, do we know where our y-axis is going to go? It's going to go to the left of 2, right? It's going to be 0, so somewhere around here, you kind of sketch it in. Good, okay. I think I'm hands off. I think you can finish the rest. So go ahead, take it all the way, state the domain range, create your box. Create your box before you plot it.
So this from the bottom to top. So it's just a massive mountain, right?
Yeah. Question?
I was going to ask him for the trinity.
Negative cosine, where am I starting? Bottom, there you go. Bottom, middle, top, middle, bottom. And then from here, some of you guys are still not liking the way you're drawing your curves. They look like straight lines. If it helps, just do parts of it. Do this part, stop. Then do this part, curve it. Then do this part, then come back down. Domain, always the same, right? Kat, what's my domain? Okay, and who's got my range? Negative 1, 2, 3. Okay.